Our base bone setup is complete, and since the last video, I went ahead and made the same constraints I showed on the right side of the eyes as well. So if you're following along step by step, go ahead and do that too. For this video, we'll be setting up the control bones. Let's take a look at what we've got in the base file really quick. We have the overall global eye control bone, and all of these other bones are children of that. Then for each eye, we have an eye control bone that controls everything on that eye, and then a bone that affects only the iris, and a bone that affects only the pupil, and then a pair of catchlight bones, and the other one is actually hidden. So there's 2 per eye. And then in the middle, we have iris and pupil bones that affect the either side. This way we can make global adjustments to the iris and pupils, or adjust only one side or another. I'll start with disabling mirror, so I can copy this bone without making another one by accident. And this will be our big eye control bone. I'll immediately assign it its custom shape and turn up its scale. Then I'm going to scale up a bit before I copy it. And this will be the iris control all. And copy that. Suppose it's a bad time to have my microphone making it so I can't see my keyboard properly. But, oh well. And now both of these need to be parented to the overall control bone. Now we'll grab these and move them to layer 1. That will be our control bone layer. Come in, make sure mirror is back on. Duplicate the eye targets, and also move those to layer 1. Now we can switch to just working on layer 1. And since we copied that, we'll need to get rid of those constraints. And these bones are going to be eye controlled left and right. And as before in edit mode, I'll scale these down a bit and then give them their proper custom shape. And now make sure that they also are parented to the overall eye control. It's got too much stuff selected. And they need to be set to not inherit scale. And the reason for that is when we scale this, I want them to go further apart, but not necessarily get larger. And now, iris control. Left and right, of course. And keeping it smaller than the other. And though that needs to be a child of that. Let's make sure, yep, that mirrored properly. And for the pupil, we'll copy the main bone again and repeat the process. Now it's getting hard to select things. And we want to make sure, let's see, that's already a child. Oh, no, it's not, because we didn't copy it. So child of, keep offset. That's working. We have this set to not inherent scale, but we do want these to inherent scale from the parent. Now that's all working. Let's see, we don't want these to inherent scale. Okay, so scaling this controller will move the eyes apart, but not actually alter their size. And I did mention the catchlight eye bones, but we're not going to add those yet. We'll add those when we get to the video about the catchlight setup. Our eye target bones from before also need to not be inheriting any scale. Next is the constraints. The iris and pupil controls need to copy the location and rotation of the control all bones. And I'll set those up off screen. Okay, so when those are set up, they should look like this. Local space, we're copying all of the scales, but on rotation, we're only copying Y rotation. And it's the same, these both target the iris, and all the pupil bones, they both target the pupil. So now, if we scale this, those both scale, or we can rotate both. And then, of course, these are inheriting transforms from the eye control through the parent-child relationship. Okay, so when those are done, they should look like this after original. I think a minute ago when I showed these ones, I might not have had this set on after original, so double check that. And again, the iris bone points at the iris controller with these constraints, and the pupil bone points at the pupil controller. So now if we use those, we can see iris bone is working, and same thing if we use the all. It's affecting both irises, and the irises and pupils are separate. And can be affected by that, or their individual controller, or combinations of both. So there's a lot of flexibility there. We're nearly done with our setup. The next step is to constrain these eye trackers to actually follow the eye controller. Currently they have a copy location, so they'll follow these root eye bones, but now we're going to give them a full copy transforms to the appropriate side's controller. And that should come before that. Now that follows that, and also we'll do it for the other side too, of course. And if we have it second, then it's overriding this, because copy transforms likes to override everything with replace. And world space is fine for this because those bones are in the same place. Now the whole setup is behaving. We can move our controller around, we can move our individual eyes around, and that's great, but there is still another issue. What happens if we move this around here? It messes up the width between our eyes because it's pointed from, well, there to there and there to there. So as you can see, as I rotated this, we're getting a different amount of distance between the eyes. So we want to make sure that these targets can't become different distances apart from this rotating it. So to do that, we will give it a damped track constraint and set that to the root bone. And we'll set that on -y so it doesn't flip around like that. Now, no matter how we move this, it's automatically going to be rotated to look at the root bone. This way, things are always the exact same width apart, unless we, of course, intentionally scale it. Our bone rig is now complete. Well, the main setup until we get to the catchlights, and now I'm going to go and lock some axes so that we can't misuse it. For these ones, I'm going to put it to XYZ Euler, and lock it on Z. We want people to use these for side to side and forward and back, but not up to and down. If they went up and down, they should use the root bone. And on this, we don't need any rotations because it can't take them anyway, thanks to the depth track. This should be able to move, but not on Y. And these should not be moving at all. They should only be scaling. And I'm selecting multiple things and holding down Alt while I do this so that it applies to all of the selections. All those can go. Those should only... actually, these are allowed to rotate on Y, aren't they? So keep Y rotation. but we don't want any like Z rotation on these. And I'll make sure my layers are correct. That looks right. Now that the bones are done, of course, the next problem is not everything is actually following the rig. The eyes are behaving properly following their controls, but the mesh, of course, is not following things it needs to. So for that, we've already got eye, left and right groups on the mesh, and we actually have these eye, left and right bones. So we want to make sure that they are deform bones, and actually we don't want anything else to be deform bones. So I'm going to disable deform bone on everything else except these two. And we will now give our eye mesh an armature modifier before the bend and point it at this armature. And now it moves. But there's other problems. It's getting distorted because not all of these other components are moving with it. We've got all of these other empties, and we've got the lattices, and these need to move with the rig as well. So we need to set up some controls for that. In my previous setup, I attached the lattices and the bend empties with the armature constraint, but that's a bit annoying because you have to reapply it all the time, so I'm going to do it differently this time. The purpose of this bone is to help us set the base position for the eye, and we want to be able to do that easily to add it to a character. So not only does it need to move the lattice and the bend object, but we don't want to have to like manually apply a bunch of things to save that position when we apply the rest pose of the rig. So the easiest way to get around that is to constrain them to the rig in world space. Now if we constrain this lattice with, say, copy transforms, and attach it to our iris or pupil bone, then it's going to get scaled and stuff with that, so we don't want that. Also, I'm pretty sure that the direction it's pointing will cause it to flip, which makes us a lot of problems, and it overwrites the scale on the lattice, because copy transform copies everything. So we're going to add a new bone to constrain these two. Let's hide those for a second. Then in the rig, we'll go to layer 2, put our cursor here. I'll add a new bone and scale it way down. And this one we're going to want to have pointing in this direction. There we go, -90, and doesn't need any roll. I'm not worried about the size. So now this is pointing in the same global location as those objects will be. And I will call this objects.l, getting super creative here. And of course, I will copy that over to the other side, because bone mirroring doesn't mirror creating bones unless you're duplicating them, which is kind of annoying, but that's fine. And these will be made a child of the eye bones. Let's make sure those are moving right. Yes, they are. They're just a full child. And now, if we unhide the lattices and target that copy transforms, it doesn't actually work because of the scale. And if we use after original, you'd think that would make it do it after this scale, and it does, but now it's doing that, and I have absolutely no idea why it does this. So forget it. We're just going to use a copy location and a copy rotation. And that's working. It still looks a bit weird because we need to add it to the bend empty too, otherwise we're changing where it bends around. So we'll use the copy constraints command. That's got that too, and those can just be default settings in world space so they get everything. And beautiful. I'll go do that on the other side. All right, now it's on both sides. That's working. Actually, I don't want this to rotate on X, so let's go ahead and lock X and Y. We only want Z rotation on these. And let's get the controls back. That's still behaving. We can do our rotation there. Wonderful. And that's pretty much everything attached now, but there's actually a couple other objects that I want to attach to our rig because they're useful reference objects. It's our reference sphere and plane. And since this has no rotation on it, and I'm going to apply the scale, and its origin point is right there, this, I think we can finally use that damn copy transforms constraint on, and attach it straight onto the object bone. Let's see. Yes, it's behaving. So now if we make a change to the rig's positioning and apply it in, apply that to the pose, our reference sphere will still follow and let us use that if we want to adjust the bend here and then scale our sphere as a reference. You could set up an automatic constraint system to automatically change the distance between this pivot bone and this bone when you change the amount of bend on the plane, but that would be a bunch of complicated drivers. But there's no reason you couldn't do that if you really want it. But I don't think it'll come up often enough. Then there's also this reference plane. This is the plane matching the size of our eye before we bent anything. And this one we haven't subdivided yet. So I'm actually going to go and give a 10 subdivision so it matches our eye still, because we will be using this reference plane for something when we get to the catch lights. So let's also go ahead and copy the same constraint to that. And why does it move? Oh, because its origin point is there. We can move its origin point to its center. And what am I missing here? How did my cursor get over there? That's what I'm missing. There we go. Now that's behaving. So now our reference objects will also stay lined up with our rig. So the only thing we have to do if we want to fit this to a character is pose it to fit the character, and then apply the armature modifier on the mesh, and then save the rest pose of the rig. The last constraint we need to set up is the limit rotations on the eye track bones. I'd already made the constraint before, but now I've gone ahead and filled it out. This stops our eye bone from going off the mesh, horizontally and vertically. And note that I put the limit rotation on the eye tracker, not the eye offset. And that's because if we change how much it copies the influence by, then we'd have to redo our limit rotation all the time. But it's actually only getting the angle it can go to is only a third of what we've actually inputted. Now, there is a weakness with this constraint, which is if we go up and sideways, it can go quite a bit further from the center, because it can go the full amount up and the full amount over. And that's bad because our eyes will probably be either a circle or an almond shape, and this will let it go further outside the bounds. But there's not really any simple solution to that. The limit rotation isn't really designed for keeping you within a distance from a point. There are more complex setups you can do to achieve that if you really want it, and I'll put a link to a Stack Exchange thread in the video description. So if you're feeling very adventurous, you can check that out. Our rig is working, but there's a couple unforeseen issues that we need to deal with. There's another bit of functionality we want. Notice that when I scale the iris, it gets bigger in X and Y, but it doesn't get deeper. And often we'll want it to, because otherwise, as it gets bigger, if we look at the glancing angle, it loses all its depth, and we can actually end up with the center being further forward than the corners. And that's not how things should look. Let's do that on both of them at the same time so we can really see it. So that's not how these should behave artistically. So what we need is, when we scale the iris control on Y, is we need to get it to get deeper. And if we look in our original file, we can see that actually happens. Not only does it get deeper when scaling Y, but if we scale X and Z without Y, it also gets deeper to make sure it never comes forward too far, even if we're just doing an X and Y scale. Now, the way this works is we have this handy driver on our displace, which modifies the strength of displace based on what the bones are doing. Let me grab a drivers editor, and we'll take a look at it. Here is the expression. And at first that might look terrifying, but let me break it down a bit for you. We have inputs of the x, y, and z of the iris empty. And then we have the base amount of displace. This is the amount of displace when there is no transform on the bones. So it's the same minus 0.002 that we have here. And then what this expression is doing is it's saying, take x and z and average them. So adding them together and dividing by 2 gives us the average. So that way, whether we're scaling on x or z, it'll have some influence. And then add the y scale, minus 1. So when y is 1, it adds nothing, because y being 1 minus 1 is 0. But anytime we get any y scale, it'll be adding that as a multiplier on the depth. So that means when y is 2, it will have been doubled from 0.002 to double the depth. Then this max 0, if you remember from our node setup where we used the maximum node to make sure that we had a minimum value. This means that if y is scaled negatively, it can't go below 0, because that gives us various problems. So let's go ahead and set that up. We need to go on our mesh to our displace. I'll copy that minus 0.002. We will do add driver. And then in this little panel is a bit annoying to use, so I'm going to go and open the full drivers editor again. And we'll need to set up our variables first. Let's get our iris object. And we'll call this x and make it local space x scale. Then we can copy and paste the variable, and this one can be y, and y scale. And we'll paste it again, because if we copy and paste, we'll copy both of them. This is z. Just click the right box. Keeps flipping which one it's on. And now let's get our expression properly. So we have the minus 0.02, open parenthesis. I'm not sure we need the whole thing in parentheses, actually. Let's try it without. Just reduce our... The main reason expressions look complicated is it's hard to parse all the parentheses visually. So let's break this down. We'll start with our x plus z, and then divide that by 2. You know, I might have more parentheses than I need because of the orders of operations, but I just used a lot, and I build them like this so I can keep track of what's going on. Then we need to add our y minus 1, and we're using that as part of a max. So max 0, comma, our minus 1 is one expression. And let's see, that's the max expression. Then these need to go in a parentheses together because we're doing those before the multiply. I feel like I'm forgetting some order of operations thing here. But let's see if that's working right now. It says invalid. Why is it invalid? I'm probably missing a parentheses. 1 parenthesis, 2 parentheses, 3. Yes, I need another one there. Aha! It's working. There, it's minus 2. And now we'll go... use our bone, and hey, it's working, but I did it on the wrong side, didn't I? No big deal. We'll just copy that driver and paste it over on the left instead. And that's working right. And now on this side, on the right side, we will edit it to be the right side empty. So drivers always look complicated because it looks like there's a lot of parts, but they're actually not too bad if you just plan things out slowly. And working. Of course, you may have just noticed that we've actually introduced a new problem now. Solving one problem often causes another. So what's happening now is as I increase the depth, our pupil texture disappears. And that's because the mesh is moving too far away from the object projecting the pupil texture. So now we have to make it so that when this scale happens, it also adjusts the pupil. And one way to do that would be to make it so that the pupil's empty object gets moved by the driver too, and moves backwards by the same amount as the depth is being increased by. But we can handle it a little bit more easily. In our original setup, we can see that this problem isn't happening. The pupil stays the same size even as the depth increases. And actually here we're having the problem that the iris is actually getting smaller as it gets too far away. So we have a easier solution than actually moving the object, though. What we're doing is we have these extra mapping nodes, and what's going on in these is another driver on Y. And we open this up. That looks pretty familiar because it's basically the same driver. So it's the same driver working on the coordinates on the vector. So the object isn't moving, we're just adding an adjustment to compensate into the vector in the material itself, so that we don't have to move the object itself. Now this expression is slightly different this time because we need to add the 0.002 in the first place in order to make the difference. And I've done this on all of our textures here. Let's see. Yeah, we've got it on that one too. So it's the same driver, so we can copy and paste it again, so that's nice. Well, we have to have a left and right version. So let's go ahead and set that up in our new file. Let's get ourselves the node editor. And put the driver editor over here again. I should have left that open. And get rid of some of these extra nodes at this point. We'll go ahead and add ourselves a mapping node. And we'll put it on texture as usual. And we only need to change the Y location. So we'll add a driver, and now it will show up here. It'll only show up if this node is selected. And now I'm actually going to go to the displace R, and copy that driver. Actually, I'll delete this one because I'm going to copy and paste it instead. And now I will paste the driver. There it is. And I can take this expression, and I think this time I do want to make sure I have the extra parentheses before I add that. So that's the right side. And then we'll copy that. And when you copy nodes, it doesn't copy drivers, which is quite annoying. If you want to copy drivers in a node group, you put the node in a group, copy the group, and then explode the group. This time, again, I'll just go and copy the left side and paste it. But on this one, I'll copy the expression that I already made. I'll go back here and paste the expression. We have to remember that this is the right and this is the left. Now let's insert those into our mapping. Oh man, which should I say is which? This is the right. So drop that in there and copy it. Copy the driver, paste the driver. Now I can hide this with Control H to make that a bit smaller. Another right side, Control H, left side. Oh, I just realized I had that in the wrong slot. Copy, put in the right slot. Oh man, getting real professional here. This is the main reason people don't use drivers more. They're super convenient, but they're so fiddly. Okay. Let's see if I did that right. When I scale this, it gets deeper. Hooray! Now it's working. So if you scale it really deep, it's going to give you problems. We could add another driver to compensate the iris even more, but I don't imagine you're going to be doing this. So this is fine for the amount you're likely to scale it. And on this side, it's also working, and we're not losing our pupils, so success. So at this point, our eyes and our rig are pretty much done. Well, at least done up to this point until we start adding more features. But yeah, that's the whole thing. They work. In the next video, we're going to be talking about a bonus, which is adding a cornea and some fake catchlights. The cornea is an extra layer of geometry that is actually displaced outward a bit, and that's useful for putting mostly transparent, shiny materials on to catch some light reflections. And the faked catchlight is, a staple of Toon eyes, and we've got some pretty fancy behavior where its position on the eye matches up with the bone's position on the rig wherever you put it. And that is made possible through even more driver magic. So the next videos on that will be talking a bunch about vectors and drivers and how to really get your bone lock, rot, and scale into your material and work with it. So thank you for watching as always. If you find these videos helpful, please consider picking up the file on Gumroad or supporting me on Patreon. I'll be putting out more content and interesting files every month. And if you get it on Patreon, it's going to be very slightly cheaper. But hey, not a big deal either way. So please like and subscribe and leave a comment if you have any questions, and I'll see you next video.